Okay, in this video I'm going to show you how to break down quantified sentences into their substitution instances so that you can do counterexamples a little bit easier. So when we're building a counterexample, we're trying to prove that an argument is invalid by giving an interpretation that shows that the premises are false. The premises are true and the conclusion is false. Okay, so we're going to do a little simpler one first. Let's have it's not the case that for all x, fx does not semantically entail for all x, x is not f. Okay, so the premise is not everything is f, and the conclusion says everything is not f. So the way we do counterexamples to show that this is invalid is to, of course, build a matrix first, which if we do this first, it's a little bit easier because it's visual. Building the interpretation first is a little bit more complicated. So we count out our predicates, and it's just one. So we have f there. We add an alpha, and if alpha is negative, that is, alpha does not have the quality f, then the conclusion, everything is not f, would be true, right? Because we only got one object, and that object is not f. And so to make this false, we'd have to change the alpha into positive for f. This way alpha is f, and so the conclusion is false. However, the premise says that not everything is f, but here everything is f, so the premise is false as well. Changing the alpha back to negative for f will switch the truth values. Intuitively, you may be able to get this problem, but I'm going to sort of break this down for you to hopefully simplify it. But let's see. The conclusion we understand as a string of conjunctions of the substitution instances. So if we were to add a second object, right, the conclusion would look something like this. And so that's how we would understand the conclusion, that A is not f and B is not f. That's how we understand the universal sentence for all x, x is not f. How we understand the premise is a little bit different. Here the negation is the one with the widest scope. And so our sentence remains a negated sentence, right? And it says that A is f and B is f, right? And so here the negation remains the one connective that has the widest scope. And here, likewise, since we understand the universal as a string of conjunctions of its substitution instances, then we understand it like this. And so here, alpha is f, right? And so it should be true for alpha, but the negation makes it false, which makes this conjunction false. So our conclusion is false. However, since alpha is f, it would be true here, but beta is not f. So our conjunction here would be false, but then the negation flips it to being true. So what we have here now is a true premise and a false conclusion given two objects, one of it being or having the quality f and the other does not. Okay, so we build our interpretation by stating the universe of discourse and adding the curly brackets to show that there's a set of two objects. And in the extension of f, we have just one object that satisfies that quality. And that object is alpha. And so there's our interpretation, there's the matrix representation, and that shows that the argument is invalid. You may not have to use that method, but in more difficult problems you may have to use that method, and the more difficult problems are the ones with multiple quantifiers. So for instance, let's take this. For all x, there's a y such that y is g, or if y is g, then x is f, right? This does not semantically entail that for all x, if there exists a y such that y is g, then x is f. Notice here there are, of course, two quantifiers per formula, per sentence, right? A universal and an existential. But in the conclusion, the existential is embedded into the universal. That means that this quantified sentence right here is actually the antecedent to the conditional, where this existential is outside of the scope of the conditional. So the conditional is actually under the scope of the existential. And so if you look at this, there's a very slight difference, but the difference will make it sort of difficult to see. So to start with the matrix representation, we count out our predicates. There's G and F, and then let's add one object, right? And let's say this object has neither quality, right? If this object has neither quality, then our conclusion is true, and so is our premise, right? So here we understand the conclusion as this, since there's only one object, right? For all x, if something is g, then x is f, right? So since there's only one object, if a is g, then a is f, is how we understand this sentence. But if you look over here, because there's only one object, we understand it in the exact same way, right? Because this is the only substitution instance. And so both of them break down to be the exact same. So what we actually need, to do is get another object, right? And then let's try to understand these sentences differently to see the difference. So I'm going to move up a little bit. Okay, so to break this down with two objects, first we need to remove the quantifier that is to the utmost left, right? And so when we remove this, we substitute for x. And so what we get is a string of conjunctions with an existential formula. And it looks like this. There's a y such that if y is g, then a is f. And, right, there exists a y such that if y is g, then b is f. Right, and so this is how we understand the premise. To break it down even further, this becomes a string of disjunctions, likewise with this. So it would look like this. Right, and so the constant remains the same. The disjunction, I'm writing it like this because I'm going to run out of space, but you can write it over here if you wanted to. But here, when we replace and remove the existential and understand it as a string of disjunctions, we replace the y with our two objects, A and B, for alpha and beta. Okay, and then the conjunction remains the main connective, and then we understand this in the same way, right? GA arrow FB or GB arrow FB. Okay, so this is the full analysis or full breakdown of the premise with two objects. Let's do that for the conclusion. So we're going to run out of space. Okay, so you notice here that the antecedent, right, is an existential sentence, but the main connective, right, sorry, it should be like this. Oops. The main connective here in the conjunct is the arrow. So this is a conditional, right? And this is also a conditional. So since this is the main connective, it remains a conditional once we break this down. So the conclusion is actually understood as, right, either A is G, whoops, or B is G, arrow, A is F, right, and A is G, or B is G, arrow, FB. Right? Sorry, it's getting a little messy. But this is how we understand the conclusion, but this is how we understand the premise. So now it's a little bit easier to see how we can make this false, right, and this true, right? In order for this to be false, right, alpha must not be G, nor beta to be G, right? We would need, if we need this to be false, I'm sorry, that either one of these has to be true, and this can be false, right? And so alpha is not G, so we can leave it there, right? But something has to be G, so let's make beta G, right? So that's true, that becomes true. True arrow false is false, right? And so because this arrow is false, it also makes the conjunction false. Okay, what about the premise? Now, if we look at the premise, right, for this to be false, right, both of these have to be false. But if you look here, alpha is not G, so that's, I'm sorry, that's false. Right, alpha is not G is false. And if that's false, the conditional is actually true, right? It doesn't matter what beta is, right? It's false here, but false arrow false creates a true conditional. If it's a true conditional, it makes this disjunction true, right? And likewise here, because alpha is not G, that's false. Alpha is on F as well. This makes this true, which makes the conjunction, or disjunction, I'm sorry, true, right? And so we have a true disjunction here and a true disjunction here. This makes the conjunction true. So this makes this universal sentence true, and this conclusion, which is also a universal sentence, false, just with this interpretation, right? And so we can write that out as the UD, universal discourse, consisting of two objects, alpha and beta, the extension of G, right, is only beta, right, and the extension of F is empty. And so that solves our puzzle. We've just created a counterexample to this argument. So we've shown that the conclusion is false while the premise is true. And yeah, that's how you do a sort of an analysis of the quantified sentences. Hope that helps.